Let's continue our studies of Xen. And perhaps the first thing we'll look at is network bridging. This is an important or integral part of virtualization altogether because it serves as the foundation of providing network connectivity from your DOM-Us through DOM0 onto the network. So before we actually set up Xen on the host, let's first set up network bridging. So network bridging. And certainly there are various means with which you can network using virtualization. However, bridging is by far the most common as it provides a transparent means of networking for DOM user guests. There's NAT, routing, so on and so forth. Maybe even tunneling, but bridging is the easiest to work with. So let's talk about some of the features, maybe even concepts associated with network bridging insofar as its relationship to virtualization. So, as we've mentioned, it provides DOMs with network access. And in particular, that's transparent network access, which essentially means that the DOM-Us or guests see ETH0 as raw access to the network. So provides DOMs with transparent ETHX, i.e. ETH0, which means they believe they're natively on the network, but really behind the scenes, Xen, like other hypervisors, facilitate the communications between, of course, DOM-Us, guests, and hosts. Now, bridging is common, or common means, let's say, of providing DOMs with net access. But others exist, such as NAT, for example, routing, tunneling, etc. And these DOMs or DOM-Us, let's just say DOM-Us, maybe we'll update this so that there isn't any ambiguity concerning the reference, whether it's DOM0 itself or the DOM-Us, which are guests. So these guests use virtual interfaces or VIFs, so virtual interfaces or VIFs, such as the format we've pointed out, VIF, the DOM ID, followed by the number associated with the interface to identify interfaces that link back to the primary DOM0 or the host for networking purposes. So from the perspective of DOM-U, whatever U happens to be, DOM1, 2, 3, 4, etc., interfaces are simply normal. They're presented as we already mentioned, ETHX, such as ETH0, 1, 2, etc. So they need not know that they're being bridged through this other interface. And perhaps we'll just note as a sub-comment or sub-note that IP configuration, whether 6 or 4 and or 4, are applied as normal, meaning static or DHCP interfaces. And that's done for Ubuntu Debian systems via etc network interfaces. For Red Hat, CentOS, SUSE systems, consult the appropriate files. But essentially, from the perspective of DOM-U, you continue to update the typical files using static or DHCP with whatever options are applicable, so MTU settings and otherwise. And as we've mentioned, NAT is an alternate means, but it's more cumbersome to administer, so NAT is alternative. But we should note that it's more cumbersome to administer. And that is because, of course, it has to go through the kernel routing, and rules have to be applied, and ports have to be allocated, whether dynamically and or manually, and so on. So it gets a bit hairy. So the easiest way to provide network access is via bridging. And then if you are concerned about firewalling, use a layer 3 physical device on the network to provide those features and or IP tables or the equivalent on the hosted guests. So, depending on your distribution, you may want to disable Network Manager. So usually with CentOS Red Hat systems, you'll want to disable Network Manager so it doesn't interfere with the hardwired bridging settings that we install. Now let's move on to installation, and perhaps we'll just note that. So let's say XenOS, Red Hat Systems, disable Network Manager. In other words, handle network connectivity manually using typical scripts. There's no interference. So with respect to installation, we need to install the bridge tools. So bridge tools provide us with the front end necessary to provide bridging of interfaces that then become available to Xen. So let's take a look at our environment. Now, we know that we have one box out on the wire. Let's take a look at our document quickly so we can just pinpoint that particular entry that we'll be working with, and that's going to be Linux CBT XenVM edition. That's going to be this drawing. Pop that up momentarily. So standard architecture, 192.168.75.0/24 that we use consistently. And our XenVM host will be this node, Linux CBT Ubu VM1 with an IP address of .105. It has another interface on the cluster network of 10.1.1.0.24, but that's not of interest to us with respect to this release, at least not for now. We're interested in the 192.168.75.0.105, and any guests we configure or DOM use will then be able to communicate with any of these nodes on the 192.168.75. Additionally, if we bridge this other interface, the 10 interface, and make it available to the DOM use, they'll be able to communicate with the cluster network as well. But again, that's not important at this particular point. So we'll be talking to Linux CBT Ubu VM1 at .105. And its host name should already be configured, so we should be able to SSH into it, Linux CBT Ubu VM1. If not, we'll configure the DNS, we'll find out. Now it shows that a key already reflects usage of this offending key at 23, so we can just update that, finding that key and just checking the lines. That should be this one here, and then we should be able to reconnect and accept the new key. So at 1.105 was associated with a different public key. So this will give us access to that remote system. Now this system has a lot of resources for us to play around with virtualization. Bridging is the important tool. So let's do an aptitude search, bridge utils, see whether or not it's installed. Currently not. So we'll aptitude install it, and that'll get us going momentarily with the bridge utilities. And then while or shortly after it installs, we'll take a look at the current interface layout to see how things look. So we'll place that in here. If it's Ubuntu Debian, so Ubu Debian, just follow the equivalent for your distribution if you're using Red Hat, XenOS, SUSE, etc. to install bridging utilities. Now once it's installed, we can check whether or not a bridge has already been defined by using bridge control with the show option. So this reveals currently defined bridges for which there should be none. So let's go ahead and do a bridge control show just to see whether or not there's anything defined. Nothing. No bridges, no IDs, no spanning tree, no interfaces. And that's fine. Now let's take a look at the main interfaces using ifconfig. So perhaps as part of this installation, perusal of environment, and that's going to include, of course, a simple ifconfig, get to know the environment, so interface configuration. Now let's see what we've got going on here. So we've got ETH0, 192.168.75.105, and loopback. And that's fine. Now we'll be bridging on this ETH0 interface and using it to communicate with nodes that are on that network, such as the default gateway 75.1. So our DOM use will be able to, when this is configured properly, communicate with our router and other nodes on the wire. Let's do an ifconfig all. See what the current configuration shows us. Here's an ETH1 that's currently unconfigured. This is the interface that's connected to that cluster network that we showed you, the 10.1.1, but it's currently unconfigured, and that's why it shows no IP address. It's currently not up, but that's fine. We're not interested in ETH1. We're interested in ETH0 as our bridge interface. So ifconfig reveals that for us. So how do we go about bridging, and what's entailed? What's involved? Well, let's take a look. This is going to be A for this section here. And let's bridge ETH0 via the etc network interfaces config file. So what's involved is as follows. We need to move the IPv4 configuration off of the primary interface ETH0 and onto a bridge interface, and reconfigure ETH0 so that it becomes a pass-through interface which will facilitate one or more bridges. So it is necessary to transfer ipconfig from ETH0 to bridge interface, which for us will use the common convention of XenBridge0. That's what Xen looks for. Let's just note Xen uses first described or available bridge interface reflected in bridge control show dump, and that's usually XenBridge0. So Xen is configured to look for a XenBridge0 interface, so we'll stick to convention. Let's navigate into etc network, modify the interfaces file, and have a look. So we've got an automatic configuration associated with ETH0. Now the auto will remain, but some things will change. Now, to avoid any confusion, we can always comment what's here and make some new entries. And let's say we comment this whole block, and maybe we just include as well LCBT classroom XenVM. So this indicates that we've made all these changes. So we want ETH0 to automatically be brought up when the system comes up. So we'll include an auto ETH0 descriptor. But rather than have the interface be assigned a configuration statically, as is currently the case, or say dynamically via DHCP, we want the interface to be assigned manual, which means we will assign, or perhaps via scripts, the configuration. This will allow us to pass the information over to the bridge. So let's further elaborate. So instead of iface ETH0 inet static, static becomes manual. And you can consult the interface's man page to see the options associated with bringing up an interface. So as it stands, this is all we need. We no longer need any IP configuration or DNS or gateways or map masks or broadcasts or so on. We just need a manual interface. So let's just say define pass-through bridge interface on ETH0. That sets ETH0. Now we define the all-important XenBridge0 interface using auto XenBridge0. It'll receive all of the configuration that was once on ETH0. This is how the pass-through will work. However, that should not be confused to mean that your DOM-use will use the IP address 105 as a default. It's simply a means with which to tell the Linux kernel that the interface ETH0 is to be used as a bridge interface, with the first bridge described as XenBridge0. For communications purposes, local access from this server will still be sourced as 192.168.75.105. Each DOM-U will be assigned a distinct address within its own container using DHCP or static configuration. So let's assign the address, and this is going to be auto XenBridge0 interface XenBridge0 inet static. It'll be a static interface with an address of the following: 75.105. That's the primary address associated with ETH0, so that it won't change. A net mask of the same. We could just copy and paste settings. A gateway of the same. So we're just transferring the interface configuration. DNS the same. And 102. And the magical settings come in with the following directives, and they're bridge related. The all-important bridge ports ties this interface XenBridge0 to ETH0. So that's going to be bridge ports, which we do not get without installing the bridge utilities, which we've just installed, or we won't be able to at least see and make use of it to determine whether that's actually running. So bridge ports, ETH0 does the binds. We can even include a comment here. So binds XenBridge0 to ETH0. That's what that directive does. And there are a host of other directives, such as the enabling and disabling of the spanning tree protocol, bridge forwarding delay, and bridge max wait, which you'll find on the net as common settings that can be associated. They're not necessarily required, but suggested. So we'll stick to convention, enable spanning tree. Sometimes you'll find in environments that enabling spanning tree will cause problems with respect to IP configurations of your DOM use, but we'll set it to on for ours because we know it works. And let's just note that this enables spanning tree protocol. And we should just also note disable if IP configuration issues in DOM use. It could be a problem depending on your network configuration, but for us it works, so we'll set it to on. Let's set the forwarding delay to 0, so there's no delay in forwarding packets on this bridge, so that disables bridge forwarding delay. And again, it's not absolutely required, but suggested. And then finally, the bridge max wait will have it wait for nothing, so no wait, let's say, no wait time. We're trying to cut latency, that's what these settings help with. So bridge max wait 0. There's always latency, but if we can reduce it through some directives, then it's helpful. So these are your key settings. Bind ZenBridge 0, and the same could be for ZenBridge 1 for subsequent bridges, but we typically bind one bridge to one interface. It's usually a one-to-one mapping, so ZenBridge 0 to ETH0, ZenBridge 1 to ETH1, and so on. Enable spanning tree, which may or may not cause a problem for your network. Disable forwarding delay so that packets move faster across the bridge interface onto ETH0. And no maximum or bridge max wait 0, so no waits on the bridging communications. So that gives us the basis with which to set up the bridge. Now, how is this going to work? Well, you can reboot, you can restart your networking. A variety of methods exist to see whether or not this will work. Let's say we go ahead and reboot. Again, let's just cat interface just to be sure. So ETH0 is going to be a manual interface, iNet ETH0. ZenBridge 0 is going to be a static interface with the same IP address that's currently now assigned to ETH0 105. It'll bridge to ETH0, spanning trees on, FD, bridge max wait, both set to 0. That should be set. At this point, we should be able to restart this node and connect to it momentarily with the same 105 address and confirm bridging. Now, if we bridge control show at this point, the bridge is still not defined. You can also try to restart the networking, but it's usually suggested that you reboot the host at this particular point because sometimes there can be problems with the network communications. Or, for example, let's say Network Manager interferes with your configuration post-reboot. At some later point, it could interfere with your virtualized environment and cause interruptions in access. So let's just note, and perhaps we'll do this while we reboot. Let's go ahead and reboot that. Now to reboot that node momentarily, we can send some pings on an interval every 2 seconds to that target system, and that'll tell us eventually when it comes back. And those are your settings. So perusal of environment and network interfaces. So what we want in here is as follows. Bridge. We're going to have an auto on ETH0. And it'll become iFace ETH0 iNet manual. And this offloads its configuration. Then we want an auto on, that should be down here, ZenBridge 0. And it'll become an iFace ZenBridge 0, the first bridge interface of type static, with your typical settings associated with the address. So for us, that's 192.168.75.105. The net mask, 24 bits. The gateway, .1. So it's just an offload, nothing else. And optionally, DNS name servers and other options such as maybe MTU settings and others that make your networking environment function. So 102 will be here, but the important create bridge, let's say. Let's see if this is back up at this point. It's actually up, so we can just copy and paste this. So let's SSH back into it. And in fact, let's copy our key since we're going to be using this quite often. So SSH copy ID over to that node. And momentarily that'll give us access. Let's cat etc network interface. In fact, we didn't SSH. Let's try it again. And we'll cat etc network interfaces, and it's found two keys. We'll have to clean up key number 23 as it's listed above. So these are the other directives that make the bridging work. If you do that and your system reboots successfully and you're able to access it, then you've successfully set up a bridge, but of course confirm with bridge control. So B bridge control show confirm presence of bridge. This is the all-important step, because once it shows, then you know Xen should have no problems using it. So let's do a bridge control show. And there we see our first bridge. Every interface, every layer 2 interface is assigned a unique MAC address. The Linux kernel is no exception. It assigns a unique MAC address, 48 bits to it, so it's automatically signed. Spanning tree is turned on, and it's bound to ETH0. If we do an if config at this stage, just so you see the lay of the land at this point, ETH0 doesn't reflect IPv4 settings. It has loopback, link local, INET 6, but not for IPv4. However, XenBridge 0 has our original 105 address. Again, this is not to be confused with the DOM-use. Again, let's just note that to be clear, DOM-use will not default to using the IP associated or bound to XenBridge interface. Let's just say rather the host or DOM0 will use the IP bound to XenBridge 0 interface. And let's just also note that XenBridge 0 merely becomes a pass-through interface insofar as L2 communications is concerned. So that essentially means that when Xen passes XenBridge 0 into the DOM-U, that DOM-U will formulate packets on its ETH0, send it in through XenBridge 0, which then gets sent out onto ETH0, which can then communicate with the rest of the network with the appropriate IP configuration. So our routing's still in place. This is still our default gateway. We should be able to communicate accordingly, send some packets out to it, for example, 192.168.75.1, maybe do a lookup of something online. Just make sure we can still get out. Maybe even see if we've got Nmap. We don't, so maybe we could aptitude install Nmap. That'll force a pull from the net to install this package. And if you're able to pull it off the net, you're looking good. usarchive.ubuntu.com. So our communications is still in place. We've got bridging in place, and that's basically step one. So let's do a netmap v www.linuxcbt.com, see what ports come back. That'll send out to the net to this IP 209.222.251. The last 16 bits comes back with common ports, SSL, so on and so forth. So we're talking to the net. So again, initially we talked about the features associated with XenVM, and then we moved on to network bridging. The reason why you do network bridging first is because perhaps the most important component of provisioning virtualization is networking. Once you set up Xen, it expects, or during the setup of Xen, it expects to find usable network interfaces, at least one. Once Xen is set up, you can then provision storage, memory, and other resources. So we've got this in place. We think we're looking good. You can reboot a couple of times, restart networking just to be sure that nothing changes. So networking, for example, restart. If you're on other distributions, just be sure that you've disabled Network Manager because it has a way of interfering. For example, this local node uses Network Manager to manage the network interface, but the remote system's a server and doesn't have Network Manager managing the interface. And Ubuntu handles the network interfaces a bit more elegantly than CentOS Red Hat systems, so it's less of an issue on those platforms, or on this platform, the Ubuntu Debian platform, than on those platforms. So we've got network bridging in place. The next step is to actually install Xen on this target system, and so far as resources are concerned, it's got 8 gigs. As far as storage, well, it's provisioned storage for its own use is 8 gigs with 6 gigs free, so there's space in there to write some files of maybe 4 gigs or so to stick an operating system. But more functionally, if we do an fdisk list, we should see that there's all sorts of storage available. So for example, Well, that's a swap. That's 8 gigs. If we scroll through SDE, that's 8 gigs. And actually, that's DevMap or LVM root. This is 100 gigs, roughly 107 gigs. This can be used under LVM. And by the way, with Xen, you'll find that LVM is quite often referenced because LVM allows us to quickly provision partitions for usage within Xen environments. So we've got a number of loose partitions that are about 8 gigs that can be used, as well as one large 100 gig partition which can be used accordingly for Xen usage. So let's move on to Xen installation.